Good morning, ladies and gentlemen. Welcome back to my YouTube channel, and today we'll be talking about sum and difference formulas. So trigonometry, Kasalian blocks. So let's start with the sum and difference formulas. So we have sum and difference. We have sine quantity u plus v is equal to sine u cos v plus cos u sine v. So we have sin u minus b is equals to sin cos cosine minus. So cos u plus b is equals to cos sin sin. And we have cos u minus v is equal to cos plus sin sin. So sin cos cosine when you talk about u plus v. So plus minus. In cosine, plus becomes minus, and cosine, negative or minus, become plus. In tangent, u plus b is equal to tan u plus tan v over 1 minus tan u tan v. So the same with u minus b, the difference is we have minus and becomes plus here. So we have here problem number 1, use identities to find the exact value of the expression. Of course, we need to find the exact value of the expression, so let's start with sine 15 degrees. Sine 15 degrees. So in sine 15 degrees, if we're going to make use of sum and difference of formulas, we have here, we could compose this one as sine 45 degrees minus 30 degrees, because these are in special triangle, 45 degrees and 30 degrees. So we need to find for a special triangle. Alright, so we have here sine 45 degrees minus 30 degrees, and also we could find that we could also have sine 60 degrees minus 45 degrees. So take note, we could make use of these two. So let's use that one. Okay, so you have different answers. If we are going to have quiz, okay, we can have two answers for this one, two processes that we could have. So first is sine 45 degrees minus 30 degrees and sine 60 degrees minus 45 degrees. So let's have first sine. Sine is equal to u plus v is equal to sin or sine cos v minus cosine u sine v. So this is the formula for sine u plus v. So let's start with sine 45 degrees minus 30 degrees. Here, in sine 45 degrees and cosine 45 degrees, we need to find first, so sine 45 degrees minus 30 degrees, we need to find sine 45 degrees sine 30 degrees minus cosine 45 degrees and sine 30 degrees. Alright, so first thing that we're going to do is we need to find for sine 45 degrees, sine 30 degrees, and cosine 45 degrees and sine 30 degrees. So first is we have the unit circle here. We'll draw here a unit circle. So of course here, okay, so if this is 45 degrees and this is 45 degrees, of course we have, if this is x and this is y, we could say that x is equal to y, right? So therefore, in the Pythagorean theorem, x squared y squared is equal to the r squared, which is the radius of 1 here. So we have here x squared plus x is equal to y, so therefore x squared is equal to 1 squared. So 2x squared is equal to 1, so therefore x squared is equal to 1/2. So x is equal to the square root of 1/2. So we could have rationalize this one, square root of 2 over square root of 2, that is equal to the square root of 2 over 2. So if x is equal to the square root of 2 over 2, of course, y is equal to the square root of 2 over 2. Okay, so of course, the result of this one, the square root of 2 over 2. So we have here sine 45 degrees and cosine. So we have now the result. So our sine 45 degrees is equal to, okay, sine 45 is equal to, sine is opposite. If this is 45 degrees, opposite over the hypotenuse square root of 2 over 2. Our cosine 45 degrees is equal to adjacent over the hypotenuse is still the square root of 2 over 2. So what we are lacking here is sine 30 degrees and, okay, we have here cosine, cos right there, cos 30 degrees and sine 30 degrees. So next we have to draw here for 30 degrees and 60. If this is the triangle, if this is 30 and this is 60 degrees, so the opposite of the angle, which is 30 degrees, is equal to 1/2, and this is 1. If this is 1/2, we have to find for our x. So x squared plus y squared is equal to 1. Again, the opposite of the angle 30 degrees, that is the rule that is equal to the 1/2 of the hypotenuse. So therefore, we have here x squared plus 1/2, then is equal to y squared rather. So therefore, x squared is equal to 1 minus 1/4. Alright, so 1 minus 1/4 because 1 squared and 2 squared is equal to 4. So x is equal to the square root of 4/4 minus 1/4. Alright, so our x here is equal to the square root of 3 over 4, or x is equal to the square root of 3 over 2. So this is the value for our x. So this is the square root of 3 over 2. So now we have here sine 45 degrees minus 30 degrees. If the value for cosine 30 degrees, so cosine is equal to the adjacent, okay, over the hypotenuse 2. And what is our sine 30 degrees? Sine is equal to 1/2. Okay, so sine 45 degrees minus 30 degrees is equal to sine 45 degrees cosine 30 degrees minus cosine 45 degrees and sine 30 degrees. Alright, so we have here sine 45 degrees minus 30 degrees is equal to sine 45 is square root of 2 over 2 times cosine 30 is equal to square root of 3 over 2 minus cosine 45 is square root of 2 over 2 times sine is 1/2. So if we're going to simplify this one, we have square root of 6 over 4 minus the square root of 2 over 4. So therefore, you have the square root of 6 minus the square root of 2 over 4. So this is the answer for sine 45 degrees minus 30 degrees. If we're going to make use of sine 60 degrees minus 45 degrees, alright, that is equal to sine 60 degrees cosine 45 degrees minus cosine 60 degrees and sine 45 degrees. So we have here cosine 45 degrees is the square root of 2 over 2. Check already. And cosine 60. The cosine 60 is equal to cosine adjacent over the hypotenuse, which is equal to 1/2. So cosine 60 degrees is equal to 1/2. Again, adjacent over the hypotenuse. Next, we have sine 60. Sine 60 degrees is equal to the opposite over the hypotenuse, which is the square root of 3 over 2. And now we have here the result. So we have sine 60 degrees is equal to the square root of 3 over 2 times 45 degrees, which is the square root of 2 over 2 minus cosine is 1/2 times sine 45 is square root of 2 over 2. Alright. So we have here, this is square root of 6 over 4 minus square root of 2 over 4. So if we're going to simplify this one, we have square root of 6 minus square root of 2 over 4. So we could say that sine 60 degrees minus 45 is the same as sine 15 degrees, and also this one. So we could produce two answers for this one, or we could have get answers as long as it is 15 degrees, but they are the same answer only here. It derives with the same answer. Alright, so we have here number 2, letter B. So tangent, so we have here tangent. What is the given? Tangent 105. Okay, tangent 100 degrees, 105 degrees. Tangent negative 105 degrees is equal to, by negative argument identity, negative tangent 105 degrees. So this is equal. So by the negative argument identities. So therefore, negative tangent 105 degrees is equal to, we can have tangent 60 degrees plus 45 degrees. So therefore, tangent 60 degrees plus 45 degrees is equal to tangent 60 degrees plus tangent 45 degrees over 1 minus tangent 60 degrees and tangent 45 degrees. First is we're going to find tangent 60 degrees. So what is tangent 60 degrees? So if we're going to have this one, right, back here, if this is 60 degrees and this is 30 degrees, so this is 1/2, and of course this is the square root of 3 over 2 based on the result of our derivation a while ago. So we have here tangent. Tangent is opposite over the adjacent. So therefore, square root of 3 over 2 over 1/2. Cancel this part. So therefore, the square root of 3. Okay, this is tangent theta. Next, we need to have tangent 45 degrees. So if tangent 45 degrees, understood that this is here like this. We derived a while ago that x and y, this is 45 degrees, is 45 degrees. This is equal to the square root of 2 over 2 and the square root of 2 over 2. So tangent 45 degrees is tangent 45 degrees is equal to the square root of 3 over 2 over the square root of 3 over 2. Now 2 over 2 and 2 over 2. So cancel this one, cancel, and cancel. That's equal to 1. So tangent 45 degrees is equal to 1. So now we have to solve for this part. Okay, so we have tangent 45 degrees is equal to, by the use of this, okay, tangent 60 degrees, which is square root of 3 plus tangent 45 is 1 over the square root over 1 minus the square root of 3 times 1. Okay, so we have here, if we're going to get the negative part of this here, because this is a negative, so okay, square root of 3 plus 1, 1 minus, this is negative actually because this is negative here. Okay, negative. So negative square root of 3 plus 1 over 1 minus negative square root of 3 times 1. The result of this one is we have negative 1 plus the square root of 3 over 1 minus the square root of 3. Multiply it by 1 plus the square root of 3 over 1 plus the square root of 3. So the resulting of this one is 1 plus the square root of 3 plus the square root of 3 plus 3 over 1 minus 3, because A minus B, A plus B is equal to A squared minus B squared. So we have here 4 plus 2 square root of 3 over 2. We could factor this one if this is negative rather. Okay, negative. We could factor this one, so negative. Okay, negative 2. Here, negative. So we have here, we could factor. So negative. Okay, so we have 2 plus 2 times the quantity, 2 plus the square root of 3 over negative 2. Cancel this part and cancel the negative. So therefore, the remaining is 2 plus the square root of 3. So this is the answer for tangent negative 105 degrees. Alright, so we are done with number 2. Number 1 problem in problem number 1, and that is letter B. So try this example for this part. Try this number 1. Use identities to find the exact value of the expression tangent 165 degrees. So try this one at home and don't forget to comment your answer. Okay, problem number 2. Use identities to find the exact value of the expression cosine 5 pi over 2, 5 pi over 12, and tangent 7 pi over 12. Alright, so we have here cosine 5 pi over 12. So cosine 5 pi over 12. So cosine 5 pi over 12 could be expressed as, okay, we have here, we could express this one as 3 pi over 12 plus 2 pi over 12. So if we're going to simplify this one, we have pi over 4 plus pi over 6. Okay. So we could express this one as cosine pi over 4 plus pi over 6. So if we're going to express this, so we have here cosine pi over 4, cosine pi over 6 minus sine pi over 4 and sine pi over 6. So what is cosine pi over 4? Cosine pi over 4 is equal to the square root of 3 over 2. No, the square root of 2 over 2, because this is 45 degrees, times the square root of 3 over 2 minus the square root of 2 over 2 times 1/2, because this is 30. Okay, so we have here square root of 6 minus square root of 2 over 4. So this is the final answer. So cos 5 pi over 12. Again, we have to express this one like this. Then cosine pi over 4, if we're going to convert that one into degrees, so we can find it that this is square root of, this is 45 degrees. Okay, and this is also sine 45 degrees based on the illustration that we had a while ago. So let's proceed with tangent. We have tangent 7 pi over 12. So we can express this one as 4 pi over 12 plus 3 pi over 12. So we have here, if we're going to simplify, this is pi over 3 plus pi over 4. So pi over 3, you have 60 degrees, and pi over 4, that is equal to 45 degrees. Okay. So we can express this one as tangent 7 pi over 12 is equal to tangent pi over 3 plus pi over 4. So tangent u plus v is equal to tangent u plus tangent v over 1 minus tangent u tangent v. Okay, so we have here tangent pi over 3 plus pi over 4 is equal to tangent pi over 3 plus tangent pi over 4 over 1 minus tangent pi over 3 tangent pi over 4. So what is tangent pi over 3? So tangent pi over 3, this is equal to the square root of 3, and tangent pi over 4, that's 40, that is equal to plus 1 over 1 minus the square root of 3 times 1. So therefore, if we're going to take this part, we have to find for, okay, we can have 1 plus the square root of 3 over 1 minus the square root of 3. So by the conjugate, 1 plus the square root of 3 over 1 minus the square root of 3 is equal times this 1 plus the square root of 3 over 1 plus the square root of 3. So we have here 1 plus the square root of 3 plus the square root of 3 plus 3 over 1 minus 3. So we have solved it one a while ago. So we come up with 4 plus 2 square root of 3 over negative 2. So we have to factor. So we have to factor this part. The negative. So we extract negative. We have 2. So we have 2 plus the square root of 3 over 2. Alright. So cancel this part. So if we're going to distribute the sign again, so negative 2 minus the square root of 3. So this is the answer for tangent 7 over pi, 7 pi over 12. Okay, so we are done with this problem. Okay, stop, try this number 2. So find the exact value of the expression using an appropriate sum or difference identity. Alright, so let's proceed now with the next part. We have here problem number 3. So write each function as expression involving functions of theta. So sine quantity t 30 degrees plus theta and tangent 45 degrees minus theta. So let us have problem number 3. So we have here sine 30 degrees plus theta. Alright, so sine, we can express as sine 30 degrees. We have cosine theta plus cosine 60 degrees sine theta. So sine 30 degrees based on this is 1/2. This is cosine theta plus cosine 60 degrees is equal to the square root of 3 over 2. Based on the solution that we had a while ago, we have sine theta. So if we're going to have this one, LCD, we have 2. We have cosine theta plus the square root of 3 sine theta. Okay, so this is the answer for letter A. So in letter B, so tangent, we have 45 degrees minus theta. Right. Okay, let's check. So tangent 45 degrees minus theta is equal to tangent u minus tangent v over 1 plus tangent u tangent v. Okay. So we have here tangent 45 degrees minus tangent theta over 1 plus tangent 45 degrees times tangent theta. So we have a tangent 45 degrees is 1 minus tangent theta over 1 plus, this is equal to 1 times tangent is tangent theta. So therefore, this is the answer. 1 minus tangent theta, 1 plus tangent theta. Alright, so let's proceed now with stop. Try this number 3. Use identities to write the expression as a single function of x. Okay, so let's proceed now with number 4. Number 4, suppose that sine s is equal to 2/3 and sine t is equal to negative 1/3. S is in quadrant 2 and t is in quadrant 4. So find s plus t. Alright, so let's have solution. So sine t, okay. So sine t, sine s plus t is equal to sine s, we have cos t plus cos s sine t. Sin, cos, cosine. Alright. So in the given here, we have sine s is equal to 2/3, which s is in quadrant 2. And we have also sine t is equal to negative 1/3, which is in quadrant 4. So we have to illustrate here. Quadrant 2. So if this is our sine is 2/3, because the hypotenuse, we have to find for x here. So x squared plus y squared is equal to r squared. So x squared plus 2 squared is equal to 3 squared. Okay, x squared is equal to 3 squared minus 2 squared. X is equal to the square root of 9 minus 4. That is x is equal to, since this is in quadrant number 2, so negative, so square root of 5. So why is negative? Because this is in quadrant number 2. Here x is negative. Next we have, if we're going to illustrate this, okay, so sine t is in quadrant 4. So we're going to illustrate that one. So this is 90 degrees. Sine is negative 1 because understood this is positive because this is the radius. So x squared plus y squared is equal to r squared. So x squared plus negative 1 squared is equal to 3 squared. So x squared is equal to 3 squared minus negative 1 squared. So x is equal to the square root of 9 minus 1. So x is equal to square root of 8 or 2 square root of 2. Alright, so the problem here is we need to find for sine s. Okay, sine s plus t. So first is we have to have sine s. The requirement here is we need to find sine s. Sine s is equal to 2/3. Next is cos t. Cos t. Cos t is not given. So if this is our t here, and this is our s, we're going to have here as 2 square root of 2. Cos. Cosine is adjacent over the hypotenuse. So therefore we have here the result is 2 square root of 2 over 3. Next we have cos s. So the cos s is cosine is this negative square root of 5. Cosine is adjacent over the hypotenuse. So therefore negative square root of 5 over 3. Next is sine t. Sine t is equal to negative 1/3. So now if we're going to substitute this in part here, sine s is equal to 2/3 times cos t is equal to 2 square root of 2 over 3 plus cos s. Cos s is negative square root of 5 over 3 times sine t. Sine t is negative 1/3. So we have here 4 square root of 2 over 3. Alright, 9 rather, 9 times 3 times 3 minus a negative times negative is plus the square root of 5 over 9. So therefore we have here 4 square root of 2 plus the square root of 5 over 9. So this is the answer. Okay, so this is the answer for the sum of s plus t. So we have here, try this number 4. So we have here, use the given information to find A, sine s plus t, and B is equal to tangent s plus t, where cosine is equal to negative 8 over 17, and cosine t is equal to negative 3/5, and s and t is in quadrant number 3. So we are done with problem number 4, and try this one at home. Try this number 4. Alright, so we are now in the last portion, which is problem number 5. So verify the following equation is an identity. So this is the last problem for this session. So we have sine x plus y, and sine x plus y is equal to 2 sine x cos y. And cosine alpha minus beta over cosine alpha sine beta is equal to tangent alpha plus cotangent beta. So let's start with letter A. In letter A, we have here sine x plus y plus sine x minus y is equal to 2 sine x cos y. So we have here the answer. So if we're going to have this on sine x plus y, we have sine x cos y plus cos x sine y. So this is the expand of here plus sine x cos y minus cos x sine y is equal to 2 sine x cos y. So we have here, we could cancel out this part. So we have here sine x cos y. Sine x cos y is equal to 2 sine x cos y is equal to 2 sine x cos y. So check. So this is an identity. So for letter B, we have cosine alpha minus beta over cosine alpha sine beta is equal to tangent alpha plus cotangent beta. Alright, so if we're going to expand this part, so you have cosine alpha, cosine beta, plus sine alpha, sine beta over cos sin sin. So you have cosine alpha sine beta is equal to tangent alpha plus cotangent beta. So if we're going to simplify this part, so we have separate, so cos alpha cos beta over cos alpha sine beta plus sine alpha sine beta over cos alpha sine beta. So if we're going to have this one, we have cancel. So we have here cot tangent beta plus tangent alpha. So therefore we have here tangent alpha cotangent beta is equal to tangent alpha cotangent beta. So therefore this is an identity. Alright, so we are done with number 5. So stop, try this. Number 5, so verify the following equation is an identity. So take note, we have 5 problems for try this, and I hope everyone you are going to solve this one at home. And please prepare for some quizzes. Alright, so study hard and keep it up. So ladies and gentlemen, this is your Kasalian Vlog. Thank you so much for listening, and I hope you will solve 5 try this in this session. Thank you and God bless.